This is the video on mole concept worksheet C, limiting and excess reactant. Now when you are doing questions regarding the limiting and excess reactant, you need to know what you mean by limiting reactant, what you mean by excess reactant. So the definition of limiting reactant is the reactant that is completely used up in a chemical reaction. And also the amount of product formed in a chemical reaction depends on the amount of limiting reactant. Okay, in an experiment, 1 mole of nitrogen reacts with 2 mole of hydrogen. So you have to find out what is the limiting reactant and what is the excess reactant. Okay, so nitrogen and hydrogen. So you have to look at the mole ratio. Okay, the mole ratio of nitrogen and hydrogen. So the mole ratio, the first row is always the mole ratio from the chemical reaction. So from the chemical reaction, the mole ratio for nitrogen and hydrogen would be 1 mole is to 3 mole. Okay, and then the second row would be the mole ratio of the amount of reactants used in the chemical, in the experiment. So in this case would be 1 mole and 2 mole. 1 mole and 2 mole. So what does it mean here? It means that, okay, 1 mole of N2 needs 3 mole of H2 to react with. Okay, however, only 2 mole of hydrogen is available. So hence H2 is the limiting reactant. H2 is the limiting reactant, which means that nitrogen is the excess reactant. Okay, so 1 mole you need 3 mole. However, in the experiment, only 2 mole of hydrogen is available. So hydrogen is the limiting reactant. Not enough. You need 3, but you only have 2. So if hydrogen is the limiting reactant, the other reactant, which is nitrogen, will be the excess reactant. So the limiting reactant is hydrogen and the excess reactant is nitrogen. Okay, so this is the explanation. Of course, in this example here, the question doesn't ask for the explanation, but this is the explanation if the question calls for it. How about in the second example? In the second example, same thing. 24 dm cube of nitrogen is actually 1 mole. So this is 1 mole. This is also 1 mole. Okay, there is a typo here. Now same thing, mole ratio. So the working would be like this: nitrogen, hydrogen. So according to the chemical equation, first row is always based on the chemical reaction, chemical equation. 1 mole, 3 mole. Okay, now we only have 1 mole and 1 mole. And then the explanation would be the same. 1 mole of N2 needs 3 mole of H2 to react with. Okay, however, only 1 mole of H2 is available. hence H2 is limiting reactant, N2 is excess reactant. So excess reactant, it's N2, H2 is the limiting reactant. Okay, next question. 56 gram of nitrogen. So you have to convert this 56 gram of nitrogen and 6 gram of hydrogen into the number of mole. So number of mole of nitrogen would be 56 divided by the MR for nitrogen, which is 14 plus 14, which is 2 mole. How about number of mole of H2? 6 mass divided by the MR. The MR is 2, so 3 mole. Then we have to look at the mole ratio. Mole ratio for nitrogen and hydrogen, 1 mole, 3 mole according to the chemical equation. But now you have 2 mole and 3 mole. So you can say 1 mole nitrogen needs 3 mole hydrogen to react with. Okay, 1 mole of nitrogen needs 3 mole of hydrogen to react with, which means that if you have 2 mole of nitrogen, so 2 mole of nitrogen would need 4 mole of hydrogen to react. However, only 3 mole hydrogen is available. Hence, H2 is limiting reactant, N2 is excess reactant. Okay, so if you have 2 mole here, you would need 1 mole you need 3 mole. So 2 mole here you would need 6 mole. Okay, this one you would need 6 mole. However, only 3 mole is available. So H2 is limiting reactant. So limiting reactant is H2, excess reactant is N2. Okay, now next one, 40 gram of calcium reacts with 63 gram of nitric oxide according to this chemical equation. So you have to convert this 40 gram of calcium to number of mole. Number of mole of calcium is mass divided by the AR for calcium, and the AR for calcium is 40, which is 1 mole. How about 63 gram of nitric acid? So number of mole of HNO3 would be 63 divided by the MR for nitric acid, which is 1 plus 14 plus 16 times 3, which is 48. And this one will give you 1 mole as well. Same thing, you have to look at the mole ratio for calcium and nitric acid. Mole ratio, calcium, nitric acid, according to the chemical equation is 1:2, 1 mole is to 2 mole, which means that and now you have 1 mole is to 1 mole. So what does it mean? So now is the explanation. 1 mole calcium needs 2 mole HNO3 to react with. However, only 1 mole HNO3 is available. Okay, only 1 mole of HNO3 is available. Hence, HNO3 is limiting reactant. Calcium is excess reactant. So excess reactant, calcium, limiting reactant, HNO3. Okay, not a problem, not a problem. Okay, next page. Okay, in an experiment, 4 mole of nitric acid reacts with 2 mole of sodium hydroxide. Identify the excess reactant. Same. Look at the mole ratio. Okay, mole ratio between nitric acid and sodium hydroxide. So nitric acid, HNO3, sodium hydroxide. So the mole ratio according to the chemical equation, 1 mole, 1 mole. Now you have 4 mole, 2 mole. Okay, how do you explain? So which one is excess reactant? So 1 mole HNO3 needs 1 mole NaOH to react with. So now it's 4 mole. 4 mole HNO3 needs 4 molar, it would need 4 mole NaOH. However, only 2 mole NaOH is available. Hence, NaOH is limiting. If NaOH is limiting, HNO3 is excess reactant. Okay, so HNO3 is excess reactant. Calculate the mass of sodium nitrate produced. Sodium nitrate is the product. So the mass of product depends on the amount of the limiting reactant. Okay, which means that you don't have to look at HNO3. You have to look at NaOH. So NaOH, okay, mole ratio, you have to look at the limiting reactant, which is NaOH, and the product, sodium nitrate, which is NaNO3, which is 1 mole to 1 mole. Now you have how many mole of NaOH being used? You have 2 mole. Okay, 2 mole of NaOH, which means that you would have 2 mole of NaNO3 produced. So 2 mole NaNO3 is produced. What would be the mass? The question doesn't want mole, the question wants mass. So mass of NaNO3 would be 2 times the MR for NaNO3, which is 23 plus 14 plus 48, and that would give you 62, 85. 85 times 2, which is 170. Okay, 170 gram. Okay, next question. H2SO4, 196 gram of sulfuric acid reacts with 2 mole of sodium hydroxide. Identify the limiting reactant and explain. Same thing, convert this to the number of mole. So number of mole of H2SO4, which is 196 divided by the MR for H2SO4, 2 plus 32 plus 48. That will give you number 6. Okay, this one is sorry, H2SO4. Actually this one is 64. 64 plus 32 plus 2, 100. So this one is actually 2 mole. Okay, so sulfuric acid, sodium hydroxide. So mole ratio H2SO4 and sodium hydroxide, which is 1 mole to 2 mole. 1 mole, 2 mole. Now 2 mole. Now is 2 mole. Okay, 2 mole and 2 mole. So which is the limiting reactant? So same thing for explanation. 1 mole H2SO4 needs 2 mole NaOH to react. Okay, so 2 mole H2SO4 would need 4 mole NaOH. However, you would need 2 mole would need 4 mole. 2 mole would need 4 mole, but only, however, only 2 mole NaOH is available. Hence, NaOH is limiting reactant. So NaOH is limiting reactant. Calculate the mass of sodium sulfate produced. Sodium sulfate is this. So the amount of sodium sulfate, which is a product, depends on the amount of limiting reactant, which is NaOH. So same thing, look at mole ratio between the limiting reactant, which is NaOH, and sodium sulfate. Mole ratio 2 mole is to 1 mole. Now how many mole of sodium hydroxide, which is also 2 mole. So 2 mole is to 1 mole. So therefore, number of mole Na2SO4 is 1 mole. And the question wants mass. Mass is 1 times the MR for Na2SO4, 23 times 2 plus 32 plus 64. And that would give you 142 gram. Okay, 142 gram. Number 6.